Hello everyone, welcome to Chip Confessions. Today we shall see how to write constraint to generate powers of 2. We can write the constraints in multiple ways to generate the numbers in powers of 2. We shall see them one by one. This is the first way of writing a constraint. Let us take a class. Let the name of the class be my class. Let us end that with end class, and then we have to declare a variable here. So let it be rand bit. We have to take a big number, so we are going to take like 31 down to 0. Let number be, means that the name of the variable be a. Then let us write a constraint. Let the name of the constraint be c1. Let it be enclosed in between two flower brackets, and inside that we have to write the condition. What is the condition? Means we have to generate powers of 2. For that, what we have to do is a must be equal to 2 to the power of. This is the operator to get the exponential value, that is the power. So power means here we have to generate different values for a. For generating different values of a, we have to give different numbers as powers. So that also has to be randomized. What we have to do is we have to declare another variable. Let us take it as like 4 down to 0. Let us name it as power. So this is another variable we are randomizing, and that will be act as power, so that 2 to the power of that number will be the value of variable a. So we are writing power here. So we are done with writing class and constraint. Now what we have to do is we have to randomize. For that we have to take a module. Let the name of the module be tb, and let us end it with end module. Then we have to declare the object of the class, that is my class. Let the name of the object be MC, and we can write a constructor here only. We can write inside an initial block, otherwise we can write directly when you are declaring the object. Now we have to take the initial block, initial, begin and end, and in between that we are going to randomize. And let us randomize for say some 5 times. So we are taking repeat loop and we are randomizing for 5 times. We shall begin and end, and in between that we are randomizing. MC is the object and we are randomizing the object. So we have to display the randomized output. This is a is equal to %d and then mc dot a. mc dot a because we are using a class variable or the class property outside the class. For that we have to access that property or the variable with the help of the object of the same class. So we are using this. Now we are done with the code, and now we have to run the code. We have selected the simulator. Now what we have to do is we have to run. Let us see whether yes, we are getting the values, and these are in powers of 2. But what we see is like we are getting some bigger number. We can limit it by limiting the value of power. Let us take it as 3 down to 0, and we shall run and see now what is the output. Yes, we can see we are getting like smaller numbers only when compared to previous output, and we can see 4 is repeated twice. To avoid that repetition, as I said in one of my previous videos, we can use randc here, so that the number the power holds will not be repeated in each randomization. We shall run once again. Yes, now we can see no number is getting repeated. So this is one of the ways of generating powers of 2. Let us check with another way. Another way will be like, we shall comment it now. We are modifying the same code. Let rand bit 31 down to 0a, let it be like this. What we are doing is, we are using left shift. I am just writing here, please concentrate on the design side. What we are doing here is, for example, if we take value 1 and let 1 be an int value, so it will be holding 32 bits, and as it is only 1, 31 bits will be 0 and the last bit, that is the LSB, will be 1. So this is the binary form of this int 1. Now by left shifting, what we can do is, the number of digits by which we left shift, it will give us the power of 2. For example, if we are left shifting by 3, then zeros will be there, and at the end we are getting like after few zeros, we are left shifting by 3, so this 1 will be followed by 3 zeros, and this is nothing but 8. If we are left shifting by 4 bits, then the same thing, and here we will get 1 followed by 4 zeros, and this will be 16, this will be 8. Like this, if we see, by the number of digits we are left shifting 1, we are getting the powers of 2. Same thing we are going to apply here. What we have to do here is, a must be equal to 1 left shifted by, we can write this power. We are using this power variable only, but what we are doing here is, we are left shifting instead of using this exponential operator. We can increase this value to 4 or 5. Let us increase to 4 and we shall see what result we are getting. Let us see the output now. I am going to delete this and we shall run the code. Yes, we are getting some values here. This is how we generate the powers of 2. This is the second way. And third way is like, let us comment this also and we shall see the third way. For third way, we don't need this. What we are doing here is, we are using bitwise operator. For that, we have to know the difference between the logical operator and bitwise operator. Which logical operator we are using, which bitwise operator we are using is, this is bitwise AND. And we should know the difference between logical AND and bitwise AND. This logical AND, it can give only true or false, that is either 1 or 0. For example, say we have two variables, let us say a is equal to two 4-bit variables, let us consider 0 1 0 0, and let's say b is equal to 1 1 0 0. Randomly we have taken some two values, and what happens if we use logical operator and what happens if we use bitwise operator. Let us see both examples. If we are doing with logical operator, that is a and 2 times the ampersand and then b, what this will give, as these two are non-zero values, what we have to consider here is, this logical operator work at the vector level, means it will consider the complete values. So it will just check whether the value is 0 or not. If any of the value is 0, then it will give 0. If none of the values are zeros, then it will give 1. So only 1-bit output we will get here, either 1 or 0. Then we shall see how bitwise works. If it is bitwise, let us say a and b. Here what it will give? It will do ANDing bit by bit. So what we will get here is 0 1 0 0. This will be the bitwise value here. This is how logical and bitwise operator works. So now we got to know the basics of these two operators. Now what we have to do is, we have to see how we are going to use this in our in writing this constraint to generate powers of 2. Let us say we have taken, let me write the condition first. What we have to write is, first number should not be equal to 0. This is our first condition. And the number bitwise and the number minus 1, that is the previous number, the current number and the previous number, and we are doing bitwise with the both. This must be equal to 0. This is the second condition. And let us see how this second condition works. We just saw the first condition is number must not be equal to 0. That is one thing. Okay, it is not going to generate the zeros. Then, for example, to check the second condition, let us say A is 3 now, and we are going to do bitwise with 3 minus 1, that is 2. So this will be 3 is 1 1 and 2 is 1 0. What we are getting here is 1 0. So this is not equal to 0. So this condition fails. Let us see with next condition. For example, let us say let the value of A be 4, and we are doing bitwise with 4 minus 1. What happens is 4 is 100 and we are doing bitwise with 4 minus 1 is 3, that is 1 1. Anyhow, we don't have this bit. Now the output will be 0 while doing bitwise, because this one is ANDed with this 0 and this one will be ANDed with this 0 and this one will be ANDed with 0 here. So what we get is output is 0. So as we are getting 0, this 4 will be printed as value of A, and we know 4 is 2 to the power of 2. So we got a power of 2 here. Let us check with another power of 2 whether it is working or not. Let us consider 8, and we have to do bitwise and with 8 minus 1, that is 1,0,0,0 ANDed with 111, which we can write as 0,111. So we can see here, if we do bitwise ANDing, this 1 will be ANDed with this 0, we will get a 0. Next, this one will be ANDed with this 0, we will get a 0 again. Then this one will be ANDed with this 0, we get a 0 again. Then at last this MSB 0 will be ANDed with this MSB 1 and we are getting 0 again. So this is equal to 0. So A will get a value of 8, which is nothing but 2 power 3. So we got to know how this is going to work by using bitwise AND. This cannot work with logical AND. We can check with logical AND also. First we shall check with bitwise AND and see whether this condition is working or not for the generation of powers of 2, and then we can check with a logical AND and how we are getting the result. So I am going to delete it now and we shall run the code once again. Yes, we got the output in terms of powers of 2. Just to increase the readability, that we know powers of 2 in some smaller numbers, means as we know, we just write it as some 7 down to 0. Let us see with this and we shall run the code and see, so that as it generates some smaller numbers, we will get to know, yes, we are getting 4, 32, 64 and 4. Okay, fine. So we are getting in terms of powers of 2. As I said before, let us check with logical AND. Bitwise AND is working and bitwise AND is generating powers of 2. Let us check with logical AND. Let us see what results it is going to generate. See, we are getting 1 only. Means as we have said, A should not be equal to 0. Anyhow, one number will not be non-zero. Even if it is 1 also, 1 minus 1 will be 0. Maybe 1 might not have got generated. That is the only possible case where we can get 0. Other than that, we don't have any chances of getting zeros. So logical AND will not work here. We have to go with bitwise AND only, and I am increasing it to 15 down to 0. Let us see the result now, how it is going to generate. Yes, so we are able to generate in terms of powers of 2. This is the third method we are generating in terms of powers of 2. So let us see another way where we are using system functions. We need only one variable here. So one system function is $1 of A. This is going to generate the value of A in terms of powers of 2. Let us see what is this $1. $1 is a system function which says, for the variable we are mentioning inside the bracket or inside the parenthesis, all the bits should be 0 except only one bit. Means only one bit should be high at a time. For example, if A is a 4-bit variable, A can take only 1000 or 0100 or 0010 or 0001. These are the only 4 possible values if you are using $1 and if A is a 4-bit variable. We shall see with this example only. We shall take it as like 3 down to 0 so that A will be a 4-bit variable, and we shall check whether we are getting these values. We shall take rand C so that the values are not repeated, and once all the values are completed, at that time only it would be repeated. Let us run the code now and check whether this is working or not. Okay, sorry, I have to delete this. I am getting error because of that. Okay, let us run now. Yes, 1, 2, 8, 4 and 2. Yes, after giving all the values, then only 2 is getting repeated. We shall write $B here so that we can see whether we are getting the same values as we discussed before. Yes, if we see 0001, 0010, 1000, 0100 and 0010. This is how, means at a time only one bit is set to high. This is how $1 works, and with this $1 also we can generate the powers of 2. Then we can use, this is one way, and another way is by using another system function, that is count ones. Count ones of A, this must be equal to 1. Like this also we can generate. What is this $count ones? This is also a system function. What it says is, whatever the variable we have written inside the parenthesis, and we have to give a value here. For example, if I am giving $count ones is equal to 2, then this variable A will have 2 bits set high, and this is counting the number of ones in the variable, and that count will be set to 2. For example, if it is like $count ones of A, say if it is 9, and whatever the number of bits A might have, out of that bits, 9 bits will be set to 1. That is how $count ones works. Means it is just counting the number of ones, and it is setting that many number of ones to that variable. As we are setting the count ones to 1, only one bit will be set to high. That is what $1 is also doing. $1 is a form of count ones, that is we can say it is one of the shorthand form of count ones. Directly we are setting it to 1 instead of giving it like this. So let us see how this is working. Let us increase it to say 7 down to 0 and let us run this now. I have to delete this, otherwise I'll get an error. Now we shall run the code and see the output. Yes, see, we are able to see only one bit is set to high, that is nothing but A is in terms of powers of 2. Let us see it more clearly by giving %d, means in terms of decimal numbers, so we can understand in a better way. Yes, 4, 16, 2, 128 and 8, these are the powers of 2. The other way is by using another system function, that is $count bits, and this is little bit different from what we have done previously. There we are just directly assigning the value, but what we are doing is we have to write the variable name and then what bit we are setting, that has to be written here, and then the number of bits that we have to write here. This is how $count bits is working. Let us see here $count bits. The syntax is the variable name, and whether it can be 0 or it can be 1, it can be X or it can be Z or Z also, and the number of times this has to be set in this variable, that has to be given here. It has, if it is 1 we have to give 1, or if it is 4 we can give 4 also. This is how $count bits is working. Now we have given, like we have taken the variable as A, and then what we are going to set is 1, and that must be equal to number of ones is 1. We shall run now and see whether we are getting the output or not. Yes, we are getting the values in terms of powers of 2. This is how, these are all the 6 ways we are going to, or we can generate the value of the variable in terms of powers of 2, and this is how we wrote the constraints today. Thank you so much for watching the video. I hope you try on your side also. Please code along with me so that you can have a good hands-on. Okay, this is for today, and in the next session or next class we are going to see how to write some other constraint, and in this I am not going to discuss like separate theory sessions and all for the constraint. My only intention is we have to improve with the hands-on. Theory you can read anywhere or you can study anywhere, but hands-on will come only when you practice. That is what I need from your side. So I want you to code along, and you can practice at your side also, so that you can improve your coding skills. This is how we wrote the constraint today. Please stay tuned for the next session where we are going to write some other constraint also. Like this we will be writing some hundreds or maybe even more constraints, so that you will become very much well versed in writing constraints. And I can say constraint is, you need not to fear about writing constraints and all. Constraint is very easy, only you have to have some hands-on or some practice only. Okay, thank you so much for tuning in. Thank you so much for watching this video. Please like, share the video and subscribe to my channel for such more videos. Thank you so much. Have a great day. Thank you. See you in the next session.